Good morning, all. Today we are going to discuss the previous university question paper. Okay, the topics we have discussed in the last sessions. That is module 4 and 6. So we can check the different questions that have come in the question paper from this particular modules. Okay, let me present. So this is the question paper of December 2019. We can go through the topics. That is part 2, basic electronics engineering. So the first question was, what are the different types of capacitor, and give any two applications of capacitor. So previously, before this lockdown, we have discussed the module 4 and the different types of passive components like resistor, capacitor and inductor. In that, we have already go through that topic of capacitor and the different types. Okay, so this is the capacitor we have discussed. The property of the capacitor is dielectric, capacity calculation, capacitance calculation, units, different standard values, and the different types, specifications, etc. Okay. Next is the describe the forward characteristics of a diode. That also in the previously discussed topics, contact classes, forward biased characteristic, biasing of a PN junction diode. It was the forward biasing block sessions and how the working taking place. And what was the working during forward biasing condition? What happens? The width of the depletion layer getting reduced, so the conduction taking place. That was the current conduction, and the cara comes in this region. That is positive voltage, forward biased voltage condition. The characteristic graph is in this type. Okay, this type graph. You have to mention that graph also for this particular question. Forward characteristics of a diode. Next question is from module 5. We are not discussed that one. Okay. Uh, this fourth one also is from module 5. We'll discuss it later. So next fifth one is explain the concept of cells in cellular communication. And that is the question from module 6. Okay. So what was the concept of a cell? Cell is a basic geographic unit of a cellular system. In that, a large geographic area is divided into small units, and each unit is calling as a cell. And what was the shape? Is having a hexagonal shape for covering the maximum area. Maximum area. Okay. And each cell is assigned with a set of frequency channel, and that is in the base station or tower. Okay. We have to discuss that all along with what? Along with our shared PPT. That is PPT was module, cellular conceptual and the diagram coming in the PPT. You have to mention that also. Next question is explain the formation of potential barrier in a PN junction diode. The previous question was of answer all questions and each carries 4 marks. And the next is also having 4 mark question, but the part is having a total of 10 marks. Okay, explain the formation of potential barrier in a PN junction diode. So again we are going to our notes that we have discussed in the contact classes. Okay, how this depletion layer is formed. So here is saying the formation of depletion layer. So at instant of p-n junction formation, free electrons moves through junction and begin to diffuse across the junction into p region and similarly to n region, and this causes combination of charge in that junction region. A depletion layer is created in that junction region. That is well explained in the notes. Okay, you have to mention that all along the diagram. Then next is what do you understand by avalanche breakdown? Draw and explain the reverse VA characteristics of a diode. Initially we have discussed the forward characteristics of a diode. Here it is saying the reverse characteristics. Okay, and along with this avalanche breakdown process. Back to our notes. Here we have explained the reverse characteristics while reverse biasing condition when we are applying a negative voltage to P region and positive voltage to N region, it's producing a reverse biased condition. What happens is width of the potential barrier getting enhanced, that will restrict the flow of charge carriers due to diffusion. So what happens? What happens? Only a small amount of reverse current is allowed due to the minority charge carrier flow. Okay, and the reverse bias characteristics come in this graph in this negative voltage region. In negative voltage region, we can see here this breakdown voltage. That is, in a particular negative voltage or reverse bias condition, what happens is current will enhanced, reverse saturation current gets enhanced. Okay, and what do you mean by avalanche breakdown process? Normally junction offers almost zero resistance at this point. Two mechanisms that breakdown occurs is avalanche and Zener breakdown. In avalanche breakdown, minority carriers flowing through the junction and acquires kinetic energy, and it increases and increasing reverse voltage. So while we are applying a very high reverse voltage, so kinetic energy is also high. So they break their covalent bonds and release more number of minority carriers and causing impact ionization, and the current is getting increased. Reverse current is getting increased. That about the reverse breakdown process and or avalanche process and reverse bias condition or reverse bias characteristics. Okay. Next question is explain the working of an NPN transistor. Describe with suitable sketches these input and output characteristics of an NPN transistor. These all are for module 4. Okay. Next, NPN transistors working and its input and output characteristics. So back to the notes. We know this NPN and PNP transistors. So this was the NPN transistor, operation of an NPN transistor. Two junctions and three terminals are there. That is the base, emitter, and collector. So NPN transistor is having N-type collector and N-type emitter and P-type base. Okay. So the biasing voltage we are giving between base emitter and collector emitter. So we have explained the working principle of an NPN transistor. So what happens when we are applying this forward and reverse bias in the two junction? Okay, and what is the effect of current? Different current, and we have calculated this emitter current I is equal to sum of collector current and base current. Along with it, I have to explain. It's a 10 mark question, so we have to explain the input and output characteristics of NPN transistors. So that also we have explained in the class. That is this is the characteristics of common emitter amplifier or NPN type we have explained here. That is the different input characteristics we have drawn in this graph. Input characteristics is a graph drawn between base emitter voltage and input current, base current. Okay, input current, base current. So what happens when we are changing the saturation rate, collector emitter voltage or output voltage? We see 6 volt, 2 volt, etc. Okay, and we one term was introduced, that is the dynamic input resistance, that is the change in input voltage to the change in input current. Next is output characteristics, that was the graph drawn between collector emitter voltage and output current, collector current IC, and we are making our input current IB as a constant for each measurement. It's IB equal to 0, 20 micro, 40 micro, 60 micro, etc. And what happens for changes in this IB, and we are increasing this VCE, and what happens to this current to IC, that we can well explained in its notes. Let's go through that. Then dynamic output resistance is calculated in this graph, that is delta VC by delta IC, that is calculated from the slope of the graph. Next question is from module 5, that we can explain already, but did not complete module 5, so we will discuss it later. So next is module 6. So what are the merits of AM compared to FM? Question number 10a. What are the merits of AM compared to FM? Then carrier amplitude of a given AM wave is 5 volt and message signal amplitude is 3 volt. Find the modulation index. That was the question. 5 marks question. Along with one more question is there, that is the block diagram of a super heterodyne receiver. So first question is the merits of AM compared to FM. We have already studied it. What was the merits? What's the merits? AM. AM is a amplitude modulation process. We are doing this AM process. In AM process, this the amplitude of the carrier wave is changing compared to amplitude of the changing in accordance with the amplitude of the message signal. Okay, so the changing occurs in the amplitude level. So whenever we are transmitting, the noise may affect in this amplitude level and will cause the signal distortion. Okay, that was one of the basic disadvantages of an AM system. And also while comparing the bandwidth, it's having a small bandwidth of twice of FM, but when we are comparing with the FM is a large, FM is having a larger bandwidth since it's having infinite number of sidebands, and also it's having high immunity. FM is having a high immunity towards noise since this the changes or the modulation is taking place in the frequency domain of the signal, carrier signal. So that was the merits of this FM. Sorry, the question was the merits of AM compared to FM. So, what was the merits of AM? AM detector was a simple to design. Its working is very simple. Okay, basic elementary form is using circuits of FM transmitters and receivers are very complex and very expensive. So we are not normally uh, considering that one. And also the advantages of AM is it is simple to implement, demodulation is easy, very cheap. So all are the advantages of this AM system. Okay. Then one more part was there, that is the question paper. In the question paper, we can see the carrier amplitude of a given AM wave is 5 volt and the message signal amplitude is 3 volt. Find the modulation index. Carrier amplitude of an AM signal wave is 5 volt. Message signal amplitude is 3 volt. So how we can calculate the modulation index? We can calculate the modulation index. That is, we have the modulation index having an expression Vm by Vc, that is the ratio of the maximum modulating signal voltage to the carrier voltage. So here the modulating signal voltage is 3 volt and the carrier voltage is 5 volt. So we can calculate the modulation index by 3 by 3 by 5, it's coming as zero point 0.6. Zero point 0.6 is our modulation index. Okay, that is the 5 marks question. And I'm going to write this simple calculation. Next topic is explain the block diagram of a super heterodyne receiver. Explain the block diagram of a super heterodyne receiver. So that also we will explained in the slides and also in study materials. You can go through that study materials. We have explained that. Super heterodyne radio receiver. This is the block diagram. You can see the basic 6 elements or basic 6 blocks coming in it. Super heterodyne receiver. And what was the property of a super heterodyne receiver? This one part called mixing. So the mixer is generating a intermediate frequency. That is a decreased frequency spectrum is created by this mixer by combining our incoming radio signal along with a locally generated signal, and that's generating sum of difference of the signals, the two incoming signals, then their sum of differences created, and the higher frequency component is filtered here, only lower frequency component called intermediate frequency is transmitted to the further stages. We can also see the basic waveforms coming in this topic, that is the RF carrier, amplified carrier, IF carrier, amplified IF carrier, and the detector part. We are recovering our original audio message signal from the carrier signal. So audio component is coming out. Then AF amplifier, so audio signal is getting amplified in the last block, and finally we are getting the output through a speaker. So this is well explained. The question is of 5 marks. So only just write this, draw that block diagram. If it is comes for 5 mark question. So only draw this block diagram, waveforms, and some important points like its intermediate frequency, mixing, etc. Don't write everything in detail. Okay. Just answer for the question and with respect to their marks. Next is okay. 11th question, A part. This only of 3 marks. Describe the principle of an antenna. We have discussed the antenna working principle based on the accelerated charged particle. So, how was the working? We can take these slides. So, how the antenna is radiated when a charged particle starts moving. A magnetic field surrounds it. Before that, a stationary charge will create a electric field around it. A simple charged particle is creating a electric field around it, and when we are changing this particle or when this particle starts moving, a magnetic field surrounds it, and we are changing this magnetic field, and an electric field also generated. And this electric and magnetic field are perpendicular to each other. And that is the concept or generation of this electromagnetic radiation, electromagnetic waves. And the radiation comes as how as we have explained in a YouTube video that when this particles, positive and negative particles, come together in a particular time period, and what happens, this field associated or around them get detached from and getting propagated, and this propagation speed of the CM wave is equivalent to the speed of light. And we also discuss this equation regarding this electric field. No need of writing that all, okay, because it's only a 3 marks question. The last question is, with the necessary block diagram, explain the working of a GSM system. It's a 7 marks question. We have to write in a lot to get this 7 marks. So GSM system we have explained in the lecture 5. Lecture 5, and here what is GSM? It is a spectrum band, different techniques used in GSM, and next is GSM architecture. Basically, three subsystems are there: base subsystem, network subsystem, and operation control subsystem. And one more thing is mobile station, that's combined with a mobile equipment and SIM. And we also explain the different interfaces coming in this system, that is UE, user equipment, and BTS, base transceivers is having interface, interface, and base transceivers and a base station controller as APIS interface, then base station controller and mobile switching center as A interface, then mobile switching center and other network communicate through this SS7 interface system. Okay, so GSM subsystems, what are the different subsystems associated? First is mobile equipment or mobile station is considered as a part of BSS. That consists of mobile equipment and subscriber identity module. Then base station subsystem consists of base transceiver station and a base station controller. You can see here base transceiver session and base station controller. That's two coming in base subsystem BSS. Then what is the function of BTS? BTS encodes and sort of multiplex the modulate feeds RF signal to the antenna, and it is communicated with the mobile station BSC. You can see here it can communicate with the mobile station and the BSC. Okay. Next is second. Sorry, before that, BSC, base station controller. It manages the radio resources for BTS and assign frequency and time slots for mobile station its area, and also BSc communicates between mobile switching center and different PTS. Okay. Next subsystem was network switching subsystem. Let's come on. Five different parts is there: mobile switching center, home location register, visitor location register, authentication center, equipment identity register. In that, each is having different function. SCMS is the heart of this network. Its main functions include mobility management, registration, location updating, and handoff control. Okay, and also it's manages different communication between GSM and other network. Then next is an HLR. HLR is a register that stores the information of each subscriber in a permanent or temporary fashion. Next element is VLR, visitor location register. It stores temporary data from the mobiles, that is, or new mobile station enters in that area. It's a temporary database. It's functioning for a roaming service. Next, AUC, Authentication Center. It is built for protection. Okay, that protects against network operating operators from fraud or any other attacks. And well, it's occupied in the special protected part of this home location register. Next is a EIR, equipment identity. Okay, EIR is equipment identity register. EIR, equipment identity register stores all device identification registered for this network, and the data is prevents from unauthorized mobile devices. Okay, prevents data from stolen, unauthorized, or defective mobile services. So it's also acting as a protecting part for our mobile data. Next, the last subsystem is operation support subsystem, and its the main function is dynamic monitoring and controlling of the network. And the listed functions also mentioned, that's configuration, fault reporter, performance management, storage of system software and data. I think you have to mention. So it's a 7 marks question. We have to include all along with our topics discussed in our study material. Okay. Study material I already shared in this campus software retail app. You just go through that. It's in PDF format. You have to study along with this PPT and study material. Anybody have textbooks? You have go through the textbooks also. So since these topics are basics, we have to get clear idea about all topics. So in the further higher semester, we have to study more detailed part of this all topics. So initially we have to make our base in a thorough manner. That's about the question paper of December 2019. Okay, anyway, thank you all.